So far, we have looked at animating models using the mechanism system, the keyframes, and the properties of those models in Unity. If you want to create a more complex animated model, then you need to create what's called a rigged character in a modeling package. In this example, we've got a rigged character of a horse in the Maya software. A rigged character consists of two parts. First, it has a skin, which is the outer layer of the character, and the skin has the texture applied to it. The part that is bound to the skin and allows the skin to move is the skeleton. And the skeleton, you can see here, has a series of bones and joints. Just like a real skeleton has bones and joints, the bones and joints in the character allow different parts of the character to move. For example, if we select just this joint and rotate it, it will rotate all of the joints that are a child of that particular joint down to the tail in this particular case. And the skin is bound to these joints and bones and therefore moves with them as you rotate them. And that will occur for any of the joints that you select and move, depending on where they are in the skeleton. With this back joint, you can see it, as it's rolled, it's only affecting this part of the skeleton. And it's the same in real life, how our own skin is affected by the joints that are closest to it. The most common type of rig used in humanoids or bipedal animation is a skeleton that is very similar to our own. You can see in this example here for this robot, which is based on a humanoid structure, that its skeleton system is rooted at the bottom of the hips or at the root of the spine and has a series of nodes and bones that continue out from that point up and down based on our own skeletal structure. And if you're to look at each of these particular joints in turn, which we can see in this window over here, they're named in a similar way that our bone structure is named. The root node, or the node in the center of this pelvic area, is usually called the hips. You then, from that point, have different nodes running down each leg, and you can see that in this case we've got the left leg node there. Attached to that is another left leg node which is slightly lower, and that would correspond with our knee joint. From that we have a left foot, which is the ankle joint, and below that finally we have a toe. And the same thing includes these things up the spine. So if we have a look at the character's actual spine nodes and just move up through these, we can find that at the very top of that structure we have the shoulders that go out through each arm, and then we also have the neck and the head node. So again, if we're to grab any one of these particular nodes or joints and then rotate them when the character is bound to the skeleton, then it will move appropriately. Movement in this direction is called forward kinematics. Kinematics is the study of how objects with armatures, bones and joints move. So when we move this particular joint in the shoulder, the rest of the arm automatically moves with it. So it's moving forward through all of the child objects. And also notice that when you move this node, the rest of the body doesn't respond, which is what you would want because that happens in nature. Now, inverse kinematics studies the effect of taking the end of an armature and moving it and then determining what all the different angles of these bones should be. So if I grab the end of this hand and move it, you can see how those joints are affected. This is inverse kinematics. As we set keyframes in the mechanism system in Unity, you can also set keyframes in your 3D software. These keyframes will then tween between those 2 points. In this case, we've got a frame at the beginning and a frame at the end of the animation system, which has the arm in different positions. And if we play through that, it will tween. The process of animating a complex rigged character is a matter of animating and keyframe all of these joints at different locations to create quite complex behaviors. Such complex animations are better made in 3D animation programs outside of Unity. When they're imported in, they're usually in a format called baked, which means that each keyframe is baked into position and retains all of the information. All of the tweening is removed so that there is a single keyframe at every frame in the animation. When that is then brought into Unity, you can play the animation fully without any interruption or any special consideration in the mechanim system. However, if you wish, you can edit that animation in Unity by removing or adding keyframes and working with the curves.